Hey, hi, hello. I hope you're having a great day today. I'm Aldan Creo, and I'm a technology research specialist. I work in Dublin in Accenture Labs, and today we're going to be talking about something super interesting, which is whether we can evade AI generated content detectors using just prompt engineering. Super interesting topic. I'll be super fast as well. But before we actually get started, I wanted to give you some notes about the presentation, how this is gonna work basically. So, first of all, I'm gonna try to be accessible rather than precise. If you want the precision, because I will say things that are not 100% accurate, you will have the references, the bibliography. I'll give you that at the end, so you just need to take a note and then you can look it up after the presentation. And another thing I will give you during the presentation is some pink boxes with a message. This means takeaway. This means a thing that you should try to remember after the presentation, like the important stuff. We will have one pink box for each of the sections, and that way we'll build like a basic notion of the key ideas of the presentation. So we are ready to get started. First of all, we need to learn a little bit about AI generated content detectors. Mm, this is important because it will allow us to understand how this relates to prompt engineering and evasion in general. So, for that, I just want you to have a general idea about how they work. And I'm gonna describe a specific type, there's more, but a specific type of detectors, which is a thing that we call perplexity based detectors. For that, we need to first understand how language models work. And for the purposes of this presentation, let's say that language models are just things that play a game, the game of fill in the gap. So I'll give you one example. As a hobby, I like to collect, fill the gap. I'm gonna take this phrase and I'm gonna give that to a language model. So literally, I take a language model and the language model processes this thing somehow, and it tells me that, for example, the next word that should come after this is with a 30% likelihood things. So it's 30% likely that I will have the sentence, as a hobby, I like to collect things. But it's also 21% likely that as a hobby, I like to collect books. So the language model is just completing the sentence, right? And we can pick one of the words here, and that way we can complete the sentence. So this is a sentence that has been generated by AI, and I'll give you another example. As a hobby, I like to collect bracelets. This is human written. Why is it human written? Well, if we go to the probability distribution, we can look where bracelets is. And we can see that, for example, I mean, I just literally came up with the example, but for example, we can think that bracelets is 0.01% likely. So, not likely at all. There's a very low probability, which means that the model is very surprised to see that this is the word that comes after the sentence. In other words, high perplexity means that the text tends to be human written. Low perplexity means that the text tends to be AI generated. If we repeat this idea for the whole text, we get a prediction. So it's just a way of measuring how much the model is surprised when it sees some text. That's how perplexity based detectors work. So I hope you got the idea. Now the question becomes, can we fool these detectors? Can we use prompt engineering to somehow fool them? Well, first I'll give you an intuition and then I'll really answer the question when it comes to prompt engineering. So I just want you to look at the graph here. Okay, there's a certain structure in the graph and it's different from the thing that we see on the right. It's clearly different, right? Like on the graph in the left, there's not a lot of structure. So everything is sort of, spread around. We wouldn't be able to clusterize the things. We wouldn't be able to say this is the region where human things are, and this is the region with, I don't know, things that belong to GPT-4. So we are not really able to, establish different sections where we can classify things. In other words, the thing on the left is not distinguishable. But if we go to the thing on the right, oh, that's very interesting because actually we can distinguish things, right? Like we can have different parts of the space where we can say, oh, this is the part where human things are, this is the part where llama things are, etc. So this is very important. This is very important because it means that on the left, a system wouldn't be able to detect whether something is human or not based on those features. But on the right, a system is able to detect that. If we train a classifier here, it would be able to pick up the signal and it would be able to detect whether something is human or not. So, well, what if we were able to take the thing that is detectable and make it into a thing that is not detectable anymore? That's how we can evade the system, right? If we do this, if we take this feature, I haven't told you what it is yet, I'll tell you in a second. But if we took this feature that really is detectable and we made, like, sort of change it into something that is really not detectable, oh, then we have no way to detect the text, right? So, very good, but now the question is what's each of the things? What's each of the charts that I just showed you? Well, the thing that by itself is not detectable is what we call the semantic document embeddings. So that means, in other words, what is written, the ideas, the concepts. Language models are more or less as good as humans in writing about specific ideas. Like they don't write about different things with respect to humans, but it is true that they write in a specific way. So they write about the same things. They write about mm, more or less, yeah, like the same things. The what is the same, but how they write, that's what changes. That's what is distinguishable. That's what's different. Which, in other words, just means that what needs to be targeted here is the style of the LLM. That's the key idea, the key message. What needs to be targeted is the style of the text, not necessarily the ideas in the text. So, yes, we can fool the detectors if we somehow change this style, but can we do that with prompt engineering? Well, that's when we get some very interesting insights, I'll tell you. I'm gonna show you a graph, okay? And this graph is how well a specific system, I'll tell you what it is in a second, but for now, I'll just say that this is a system that is a detector, and let's see how well it performs. So you are gonna see a score from 0 to 1. 1 is very good, 0 is not very good. And here the system is gonna focus on the style, how the text is written, right? The thing that we said was very important a second ago. So let's see what happens. When we don't do anything, we have this thing that I'm highlighting here. So we have scores that are close to 1. That means that the system is good, basically, right? It's detecting the texts. Now, the thing that happens is that when I rewrite the text, so for example, I can ask the system, regenerate the text, regenerate the essay in this case. This is a study that was done with essays. So when I ask the system to regenerate the text, you can see that the score goes down a lot. Now it's close to 0, more close to 0 than to 1, actually. So that's very important. But if I, for example, ask the system, explain to me what's the concept of perplexity. Perplexity was this thing that we mentioned before, how surprised the system is to see a certain text. So we ask the system, what is perplexity? Explain that to me. And then try to increase perplexity. So try to come up with a text that is more surprising. Well, you can see that the result is that, like, the detection just is much worse, right? Like it goes down a lot, and it also goes down a lot if we regenerate the text to avoid detection. So if we ask the system, please regenerate what is written here just to avoid being detected, it really is very effective in general. So Wow, yeah, well, this seems to work, right? Well, maybe not so much. Maybe not so much, because what I haven't told you is that this is just the GPT-2 detector, but there's other detectors, of course, and the results are not so conclusive if you look at the other detectors. So just look at the thing I was showing you like a second ago. If we look at the GPT-2 detector, very good, like in terms of evasion, right? Like the performance just decreases a lot. But if we look at OpenAI, we can see that their detector is actually not so well affected by those techniques. So, in general, can we say that prompt engineering is able to evade the detectors? Mm, I'd be a little bit reluctant to say so. I'd say that in general, in literature, we have some mixed evidence of being able to actually use just prompt engineering to evade detectors. There's other techniques that can be used, and probably I would go for that. So prompt engineering can help, but use your common sense. There's other things that you can do. You can paraphrase. You can like alter the structure of the text. Just make it sound more like you, and that will have a stronger effect. You can combine that with prompt engineering, of course, but there's more things to take into account. Prompt engineering alone can't solve literally everything. And that brings me to ethical considerations, which is a natural follow up on that. You've just seen that text detectors are not very reliable in general, right? Like they can fail sometimes. We shouldn't really trust them. Especially, we shouldn't base any sort of decisions like accusing anyone of having cheated or things like that. No, text detectors are unreliable, and if like anyone wants to, well, say that someone used AI to write something, it's very hard to prove. So that's the first thing to have in mind. But the second thing that I want to tell you is my reason for doing this talk, really. And I just believe that in general, sharing knowledge is a sort of progress, right? Like we need to talk about things to understand how they work and what are the implications. So just learning about this, I think it's like already like a leap forward. Then there is a need, and I believe that this is another of my motivations for doing the talk, really, to really consider the value of real work. And what I mean by real work is like things that LLMs can't do for us. So, for example, repetitive tasks. What's the point of doing repetitive tasks if you can just automate that? I don't think anybody should be penalized for automating their lives. So, I really think that we should try to strive to just do real work. I hope this presentation helps you focus on that part of your work, the real stuff, the things that really need like a thinking head. And I hope in general that the presentation was a little bit enlightening. But you'll be able to tell me now because this is a QR code that will get you the bibliography. And if you could fill the form, it would be very nice. It's a feedback form. I always ask people for feedback at the end of each presentation to be able to know what to improve or what to change, etc. So this will get you to the bibliography, but there's also a form, and I would really thank you if you can fill in the form, give me your feedback, and then keep reading about the things that we just talked about. I think they are very interesting. So you'll get the bibliography and you can dive deeper into the thing. You'll also have my LinkedIn, or of course, just feel free to search my name on LinkedIn and connect with me. I'm very happy to do so. So, having said that, I really hope you have a great rest of the conference, and that you learn a lot and that this was a little bit insightful. My name is Aldan Creo, and I'm happy to see you around. So, goodbye, and hopefully see you soon. Goodbye.